Welcome to the first video tutorial that we're presenting for the CNC Integrated Fabrication course. This tutorial will cover the basics of 3-axis machining, the TOOLPATH setup in RhinoCam. We'll be looking at the difference between horizontal milling and parallel milling, roughing and finishing, and we'll call attention to the basic variables that affect machine load, duration of the cut, and the resolution of the object coming off the CNC table. This is the model we were looking at in class. If you don't already have your machining operations browser open, you go into the RhinoCam file menu and open it here, but we also need the machining objects browser open, so we'll click that. Some of you have these collapsed on each other. I prefer to pull them apart so that there's a little more space, visual space to think and breathe. The first thing you'll need to do is bring in the information that was collected as our knowledge base in the Sullivan Fabrication Studio. Click on this icon. If you forget which one is which, just hover over it. It tells you what it is. Load knowledge base. Mine is on my desktop. It's the 4.0.4 distributable. I'm going to go into cut paths, and in this case we'll be cutting into foam. And open that up. It brings all the options for foam. So we've already looked at 2.5 axis cuts. We're going to be looking at 3-axis milling, and just these two, horizontal and parallel. So I want to compare them side by side, and I can always delete them from the machining operations browser. So I'm just going to drag both over so we can look at them together in simulations and close that browser. Again, it's freeing up space to think and breathe. Open these up. We'll see in both milling approaches there's a horizontal roughing component and then also a finishing component, which differs. It's either horizontal in the one case and parallel in the other. In my model, what I've done for mine's sake, and this is a habit I've gotten into as a designer in this digital space, is I define what the largest space is that I'm dealing with, and I also define what I'm looking at in terms of my model. So if I was to mill this out of 12 by 12 piece of foam, I might actually choose to move it. So I'm going to move all of this over 2 inches. Well, let's just do 1 and 1. So this gives us enough room to have a screw in that corner. Okay, I'm going to save my work very quickly. So we're set to look at the milling environment. So I'm going to set the stock first, box stock. This radio button needs to be selected. That coordinate is 0, 0, 0. I have my number lock on, so now I can get to 0 there. Our stock dimension is 12, 12, and 2 inches. Now we click OK, and we should be able to see this in all of our viewports. And we do. It's 12 inches by 12 inches, and I've got this set up. This dimension here is 1 inch and 1 inch, and each square is a 1/4 inch. Everything looks good and checks out visually. You want to make sure that you are using common sense as well as your design and rational sense. Right, so I'm just going to tell all these instructions where to look, and then also confirm which bit, and then I'm going to generate the toolpaths just to take a look at them. So you can do this with all of your work in RhinoCam, just to compare and contrast. So again, going to machining features, select the containment region, just going to select that circle, because I don't want to mill the whole surface out, I just want to mill that portion of the surface out. I'm going to save there, and automatically in the horizontal roughing in foam, the half ball mill comes up as the standard tooling. I want to change that to the 1/4 ball mill because I don't want to change the tooling in the middle of the cut. Otherwise the half is great because it moves a lot of material quickly. I'll generate that while I'm there, collapse that folder, and do the same thing for the other 3. Confirming the ball mill is selected, the 1/4 inch, it is. And to get this regeneration option, I'm right-clicking on the folder. And regenerate, even if it hasn't been generated, it's generate or regenerate. It means one and the same thing. And the ball mill is what I wanted. Regenerate. Okay, so now we can look a little closer, see what's going on. Make sure our stock is back on, just for visualization purposes. Actually, it goes away, doesn't it? So you can see that with the horizontal roughing, it steps down very aggressively. Parallel finish, or the horizontal finishing, finishes right at the surface. We have the same roughing pass, it's defined the same, and then the parallel finishing looks a little differently, but it is right on the surface as well. So you can see with this visualization, the horizontal and the parallel, the tooling goes right to the surface and does the finishing work. So it needs material to be moved out of the way before it hits that set of instructions. Alright, let's see if we can simulate this. Go to the Simulation tab. Get a better view here. Play this out. Okay, so it's doing both for us. So we're now at the parallel finishing, the horizontal finishing pass. And play that again. This is the roughing, and already down to the parallel finishing. You saw how the roughing was leaving material behind. That's because of one of the parameters, the step over parameter. I wonder why it's missing that. So there's some quirkiness going on here. Let's take a look at the simulation for the other set of instructions. Parallel finishing. Same roughing, and now this is the parallel finishing. And does a much better job at the surface. In fact, I can highlight what happened in the other one. With this, what's remaining is there was a step over amount that had the tooling not actually see part of the model. I'll try and accentuate that fact either in this video or in person in class. So things that we can change. Let's go into parameters. Go to cut levels. And we can do one thing here is we can do a step down control. And let's change this to 5 and regenerate, and watch how the tooling changes. So the contours get closer. Let's go ahead and play this back, and we'll see we're going to finally get to those islands because the tooling could see that geometry. Just taking longer. Just a more refined cutting. Okay. And if we bring this up to 30%, not going to do much work. It'll be very fast though. So it's missing a huge amount of information. So it's horizontal. Let's do the same thing for parallel finishing. And here the cut parameters that we can change are the step over control. And let's change that to 40%. Regenerate. You see the lines get wider spaced. And it's going to be fast milling, but it's going to leave some sculpting in your model. Okay. Change that to 5%. Regenerate. You get much more refined object out of the milling environment. And it's also going to take quite a bit more time. And you see it's never going beyond the circle, the center of the bit. It's It's never going beyond the circle we drew from the top view. Okay, so one other thing we could probably look at real quick is turn this dark visibility off. See if we can see from the sides. The horizontal finishing, you can see from the front view, happens in layers. So it's doing horizontal slices or layers at a time. That's where the horizontal comes from. And parallel is taking parallel paths through the model surface. All right, that's the main difference. We looked at some basic variables. We looked at the simulation environment. And there you are, basic introduction to 3-axis machining.